Harry, you had a chance to work on Microthene.
Microthene predates even me. It was developed in the 70s.
After all that time, you're right, it was created in the 70s. We still produce the powders exactly the same way, and it's a trade secret.
I want to talk about the idea to reality journey. People often think that innovation is a lone scientist in a lab, but at CTC it involves a lot of collaboration.
The point is not necessarily to have the most equipment. It is to have the right capabilities and flow so that each test answers a real question and moves us closer to a successful solution. Innovation is very much a team sport, in my experience. A group of us from ATTS and R&D were driving back to Cincinnati after the Plastic Pipes conference in Chicago. That's 5 hours in a car to compare notes. We all saw the same trend at the conference, the growing importance of low-sag, high-density polyethylene pressure pipe. We put an idea into the system right away. A month later, we ran a full-scale, successful customer trial. So the low-sag pipe product commercialized 3 years from beginning to end.
When we talk about innovation, it's easy to think of it as a vague concept. But at LyondellBasell, innovation has a physical home, a rigorous process, and a very real impact on the products you use every day. Welcome to the LYB podcast. I'm Deepi Sidhu, Content and Social Media Manager at LyondellBasell. Today, we're tracing the journey of a creation, from the first spark of an idea in a research lab to the high-tech materials you see in the world. We're starting at the heart of our North American R&D, the Cincinnati Tech Center, or CTC as we call it, to see how decades of expertise can turn a brainstorm into a global product. Then we're looking at Microthene F, a technology that's been 50 years in the making and is now poised to help revolutionize the electric vehicle industry. Our first guest, Dr. Harry Mavridis, has dedicated over 3 decades of pioneering polymers R&D at LYB. The public scorecard of his work is impressive. 25 technical papers, over 2,000 Google Scholar citations, and 31 granted patents. But his own yardstick is simpler. Lead and conduct impactful polymers research that contributes to business success. Harry's career-long commitment to the science of polymers reached a milestone in 2024 when the Society of Plastics Engineers honored him with the prestigious Fellow of the Society Award, recognizing leaders who have made truly significant contributions to plastics engineering and technology. At LYB, Harry serves as R&D Director of Product Development and Circular Design for the Americas, turning complex chemistry into polyolefins products that power our world today. Harry's here to talk about turning R&D into real value. First of all, Harry, thank you so much for joining us.
Wow, thank you, Deepi. Thank you very much for this wonderful introduction. I very much appreciate the opportunity to join the LYB podcast on innovation. Innovation being effectively the job description of my R&D team in Cincinnati, which I have had the privilege to lead for the past 5 years. We are a small team by design and high impact. Everyone has an advanced engineering degree with 2 masters and 7 PhDs, and we work as one team with a simple mandate: translate the technical solutions the market needs into polyolefin products and applications that run reliably in the plant and perform the way they should for our customers in the market. We aim to create new and improve existing LyondellBasell products, especially polyethylene, polypropylene, and catalloy. We also work on the tough technical challenges of mechanical recycling, including development work that supports the Circular and Recover brand, so customers can count on performance while we advance circularity. If I had to summarize how we operate, it's 3 things: global R&D, close and tight collaboration with our customer-facing technical teams, and alignment with business strategy and priorities.
All right, Harry, thank you so much. Yeah, leading a team of advanced engineers, that's got to be exciting and obviously contribute so much to the R&D work you do at CTC. So tell us about CTC. How would you summarize the work that does take place there in Cincinnati?
Yes, indeed. CTC is LyondellBasell's North America Polymers Technology Hub, one of 3 globally, the other 2 being in Ferrara, Italy, and Frankfurt, Germany. CTC is best in class in its scope and capabilities. We have polymer analysis and testing labs, catalyst development labs, and a world-class applications lab where we generate final applications with our products, films and pipes and tubs and containers and bottles and coated paper and a wide range of end-use polyolefin applications our customers use every day.
Looking at the history of CTC, how has that long-standing foundation really allowed LYB to remain a leading innovator? And also tell us, what it is about that specific variety of labs there that keeps us at a world-class level.
Absolutely. CTC was built in 1991 as a dedicated 260,000 square foot polymers technology center for the very same reason and purpose it serves today. As technology and markets shifted, CTC evolved with them, adding or upgrading sophisticated instruments and applications lab capabilities that let our researchers and technical teams stay at the forefront and tackle the customer challenges of today and tomorrow. So, day to day, that means having the right sequence of labs and people under one roof, analytics and characterization to understand materials at a fundamental level, compounding to formulate final products, film extrusion and molding machines to make final parts and evaluate process windows and part performance, physical testing of the parts we make in the applications lab, and product stewardship embedded so we meet standards as the work advances. The point is not necessarily to have the most equipment, it is to have the right capabilities and flow so that each test answers a real question and moves us closer to a successful solution. One example of new lab capabilities that helps us is the new Collins cast film line, which expands on our on-site cast film capability, letting teams rapidly prototype and evaluate flexible packaging structures. Include multiple pouch formats for customer trials and demos.
Harry, let's talk a little bit about that path of innovation itself. So people often think that innovation is a lone scientist in a lab, but at CTC it involves a lot of collaboration. Tell us how the R&D teams and the application teams actually work together to move an idea from whiteboard to production and what that daily collaboration looks like.
Yes, indeed. Innovation is very much a team sport, in my experience, at least in our business. How it works in practice? Sometimes it is market pull. A need comes in from the market and we work to find a solution. Other times it is technology push. We have developed a solution in R&D and look for the right market problem to solve. Our low-sag pipe development was a market pull. High-pressure polyethylene products were a technology push. In both cases, though, you need a place where market needs and technical solutions meet. That's what we have here at CTC through the collocation of what we call ADTS, Applications Development and Technical Service. This is our customer-facing and market-facing team. That's on one hand. And the other hand is us in R&D, the technical solution providers. When a market need is identified, market need being typically either a product or an attribute that creates customer value, it often comes in through ATTS at CTC. We have a formal intake to capture, categorize, and process ideas. An idea hub reviews them against criteria, including value and strategic fit. Our ADTS and R&D experts jointly review promising ideas and may launch formal projects. Depending on complexity and how far upstream we need to go into the polymer manufacturing part, whether in the reactor or catalyst, etc., we either handle development locally in Cincinnati and go then directly to the US manufacturing plant, or we involve our European R&D teams, where we have pilot plants and catalyst development capabilities. That's when a major reactor recipe program is required. For example, the Hyperson was that case. And it is often the case for polypropylene and catalyst products.
You talk about identifying a market need. I want to talk about the idea to reality journey. You have a great story about how a road trip back from a pipe conference actually sparked an idea for you.
Indeed. Back in 2014, I think, a group of us from ATTS and R&D were driving back to Cincinnati after the Plastic Pipes conference in Chicago. That's 5 hours in a car to compare notes. We all saw the same trend at the conference, the growing importance of low-sag, high-density polyethylene pressure pipe. These are very large diameter pipes, anywhere from 3 to 10 feet in diameter, and very thick walls, from 3-inch thickness to 5-inch thickness and above. We put an idea into the system right away, and I kicked off a project myself. And we started with a brainstorming session on technical pathways, followed by scouting experiments in the CDC labs that quickly identified the leading candidate. We mapped the recipe in the lab over a few months and then scaled up to the manufacturing plant. A month later, we ran a full-scale, successful customer trial, so it was less than 9 months from project kickoff. Plant-level optimization followed, then comprehensive pipe testing and certification. That's very rigorous and lengthy. It takes about 1.5 years. So the low-sag pipe product commercialized 3 years from beginning to end and was later improved further with an additive package for chlorine resistance. Today, that product is one of our most significant products by volume and value. And by the way, several of the CDC colleagues in that 2014 car ride back from the conference were later named co-inventors on a US patent for this technology, a nice full circle moment.
Fascinating story. And yes, a really nice full circle moment, Harry. Thanks so much for giving us an inside look at the CTC and the R&D process here at LYB today.
Thank you.
Harry's story shows us how we can solve big problems with big pipes, but innovation at LYB also happens at the microscopic level. That brings us to our next guest, who is looking at a technology that is ultra fine in size, but huge in potential. Joining us now is Sam Sinozich, our Microthene Business Manager. Welcome in, Sam.
Thank you.
All right, to get us started, tell us a little bit about what you do at LYB and how your role really bridges that gap between the lab and the market.
Of course, I'd love to. And thank you so much for having me on today. So as you mentioned, I'm the business manager for Microthene within the Engineered Plastics division of APS. This puts me at the crossroads of customer demand and product innovation, but I get to use one of the most interesting and unique technologies in the LYB portfolio. My role covers everything from customer outreach and building relationships in our core markets, all the way to product innovation for high growth and high potential opportunities for the industries of tomorrow. This pioneering mindset is what ensures that Microthene is not just a product line, but it's a technology platform that enables APS to innovate for solutions tomorrow.
Yeah, it's a result of decades of expertise in R&D and tech centers like CTC, also a global network that really helps turn a great idea into reality. Can you tell us a little bit more about that?
I absolutely agree. In fact, Microthene F wouldn't exist if it wasn't for such a long history of inventors and innovators, of process engineers, and of chemistry and technology leaders, all supported by technology centers like CTC. These innovation hubs provide the right collaborative environment to advance products, to develop new chemistries, and to advance specialty products beyond commodity markets. I mentioned a long history, and in fact, Microthene F was originally created and commercialized at the Tuscola, Illinois site almost 50 years ago. Today, our products are produced within the LYB Technology Network in Odessa, Texas. All of this proves that at LYB, innovation runs in our blood.
It does run in our blood. And you mentioned all these different sites, and it's funny, before the podcast, we were chatting with Harry. Harry, you had a chance to work on Microthene not 50 years ago, a little bit more recently than that, but tell us about your experience with Microthene.
Yes, I worked on Microthene in 1994 for a little bit, and I had to delve into the history of it, and Microthene predates even me. And back then, CTC did not exist, but the lab before that, it was called CRL, Cincinnati Research Lab. That's where the Microthene was developed in the actual lab, and then they built a pilot plant right next to the labs, and then it was scaled up from that pilot plant to the Tuscola plant.
So imagine, Harry, after all that time, you're right, it was created in the 70s. We still produce the powders exactly the same way, and it's a trade secret. No one in the industry has ever figured out a way to produce powder just the way that we do.
Fascinating. Well, how would you describe Microthene in its everyday applications uses?
Sure. It's important before we talk about the applications to understand more about the product itself. It's so interesting and unique. These powders provide enhanced dispersion, better processability, and high-end performance. Our customers prefer these materials for their end-use applications, many of which we use today. In fact, the next time that you go take a drink of cold water out of your refrigerator, out of your filtration pitcher, you're probably going to be benefiting from an enhanced filtration block that uses Microthene as a binder to hold all these filtration elements into a rigid matrix.
There's such a long history, and you keep evolving it and coming out with new products and new technologies. What can you tell us what's next for Microthene?
Well, I'm glad you asked. Our team is poised to capture advancements in the rapidly growing electric vehicle market segment. We're using the same type of science that we just discussed with carbon block filtration to solve one of the biggest industry problems with an EV. It's to move away from liquid-based solvents in the battery cell assembly step. Microthene is a dry binder, and so when you use Microthene to assemble a battery cell, you greatly reduce the energy requirement to do so. This provides a cost savings to our customers. As we look ahead, we're very excited to announce that we'll be partnering with Nexeo, hosting a webinar in Q2. We will be doing a live demonstration and digging into Microthene at CTC. We will be showcasing many of the advantages of Microthene at a deeper level, and we'll go into just how we're poised to capture advancements in the industries of tomorrow.
Love it. So excited to see it. And great news, exciting news for both of you. Thank you so much, Sam Sinozich, Dr. Harry Mavridis. Thank you so much for joining us today. And if you enjoyed this inside look at innovation, be sure to subscribe to the LYB podcast on your favorite platform so that you don't miss an episode. And for more stories on how we are creating solutions for everyday sustainable living or more about webinars on Microthene, be sure to visit lyb.com. Thanks so much for listening.